So in this lesson, we are going to learn the difference between independent events and dependent events. So independent events are events whose outcomes do not affect one another. So for example, if you roll a die and flip a coin, it doesn't matter what you get when you roll the die, that will not affect the outcome when you flip the coin. Dependent events do affect the other's outcomes. So for example, if you are choosing something without replacement, so when you're dealing cards from a deck, you deal one card, you don't put it back before you deal the next one. So that changes the probability of that second card. So our objective today is to be able to calculate the probability of independent and dependent events. We're going to take a look at the independent events first. So the probability that you roll a 2 and flip heads. So in the last lesson, we saw how to calculate the probability if it was an or probability, and we added those probabilities together. With and probabilities, we are going to multiply. So anytime you see the word and in a probability, you'll want to multiply. When you see the word or, you're going to want to add. So the probability that we roll a 2 is 1 out of 6, and we're going to multiply. The probability that we flip heads is 1 out of 2. Remember, when we multiply fractions, we multiply straight across, so we get 1/12. Dependent events. So remember, this is one where the second probability changes because of what happened in the first event. So we're eating a bag of Skittles. We've got a bunch of different colors in there. What's the probability that he eats a red and then a green? So for the probability that he eats a red, that's calculating the probability normally. We've got 9 reds out of a total of 14, 26, 35 Skittles in the bag. We see the word and, so we want to multiply our probabilities together. Now, once he's eaten a red Skittle, there are now 34 Skittles left in the bag. And then a green, we still have 8 greens in the bag. So multiplying our probabilities together, we get 72 out of 1190. So if we want to simplify this probability, I would actually simplify it before I multiply. 8 and 34 have a common factor of 2, and I don't see any other common factors, so that would give us 36 out of 595. Last slide, we're taking a look at determining if the situation is independent or dependent, and then we'll calculate our probability. So in our first example, we have a bunch of people who received top honors for an essay from different classes. We want to know what's the probability that the first person chosen is a junior and the second person chosen is a senior. So think for a second whether or not you think the events are dependent or independent. So in this case, because we are choosing one and their name is not being replaced, we're not going to choose the same person twice. This would be a dependent event. So the probability that we get a junior and then a senior, we have 4 juniors out of 12 people, and we're going to multiply. There are 5 seniors, but now once the junior has been drawn, there are 11 people left to choose from. 4 12 simplifies to 1/3, so we end up with 5 33rds for our probability. Last example, we've got a 12-section spinner. What's the probability that we spin an even and then a prime? So this would be an independent event because when you spin the spinner, it will not affect what you get the second time you spin. So probability even and then prime. While half the spinner is even, and with the and probabilities where we multiply, it's nice to go ahead and simplify those right away. And then a prime. Remember, a prime number has 2 factors, 1 and itself. So 1 is not prime, 2 is prime, 3 is prime, 4 is not prime, it has a factor of 2, 5, 2 is the only even prime, so we can skip 6, 7, 9 has a factor of 3, 11, and then 12 is not prime. So we have 5 out of 12 numbers that are prime. So multiplying straight across, I get a probability of 5/24.